Hey guys, welcome back. So today I brought home this 5500 watt Powermate generator. This is powered by a Yamaha MZ300 engine, and I found it on Facebook Marketplace for $200. According to the listing, the engine runs well, but this generator doesn't make power. And $200 for a generator that doesn't make power, that's a lot of money. So I offered him 100 and we agreed on 140, which I think is a good deal. I mean, these engines are well built, and I've seen several with well over 1,500 hours, and they were running strong. Unfortunately, I wasn't able to start this one. The tank was empty, and the seller didn't have any fuel, so we could have issues there. Anyway, worst case, I have another generator with a blown engine that I think this one could go in its place. But before tearing this thing down, I want to do some tests and just make sure that this Powerhead is terminal. So let me get set up a little bit better and get going on this. Hopefully you can see the multimeter okay. I've got it turned on and set to ohms. Now on 240 volt generators, there are two main windings, and usually it's wired in such a way that you have leg 1 on one set of outlets and leg 2 on the other, but not always. If there's any doubt, you can use the 240 outlet. You have the ground here with this tab, neutral, and then leg 1 and leg 2. So that's where I'm going to test. And generally I see between 0.3 and 0.4 ohms. And if you're not sure, the reading should be consistent between leg 1 and leg 2. In this case, we get 0.6, 0.5. That's a bit high. I would expect it to be around 0.4, 0.3. So it's not terrible, but it is high. Let's check the other leg. A little bit lower. We got 0.5. So there is a slight difference between the two, but not much. So no red flags here. I wouldn't say based on that we have a bad stator. So I'm going to get the tank out of the way. It's actually missing its hardware, so that'll be easy to just lift off. And there is a quick disconnect back here. I want to unplug that, check it directly on the wires that go down to the stator. That's also going to isolate it from ground, so I can check each of the coils again to see if the reading's any lower, because sometimes resistance can be introduced in the control panel, especially on the circuit breakers. So we'll eliminate that from the equation, check it direct, and see what we see. This connector has 5 wires. There are 2 that are black and 2 that are white, and the center one is green. That is the ground wire. So the way they usually wire this is that one of the legs is diagonal from each other, and then the other leg is diagonal the other way. So let's just do the same test and see if that resistance is any lower. 0.4, 0.3. That seems like a good reading. Let's check the other leg. .4, 0.3. So that's good. Leg 1 and leg 2, it's what I'd expect them to be, and they're consistent when testing directly down to the stator. Now, since we have it isolated, there's 2 more tests we can do. First is we can check each leg to ground and make sure there's no connection. So I can touch it to the engine, or we can use this ground wire in the middle. There's no connection to ground. We'll check the other leg. no connection to ground. That's good. The last test we can do is just check between leg 1 and leg 2. And that's like the ground test. It's just making sure there's no failure in the insulation. And we get nothing. So it would actually seem like the stator is healthy on this generator. So I'm inclined to think it does work. Potentially there are issues with the brushes or the rotor. So let's take a look down on the end cap and see if we can't do any tests down there. I don't know if this is brushed or brushless, but if it is a brushed generator, the brushes will be right behind here. And yeah, this is a brushed generator. So let's get those screws out. We'll disconnect the brushes from the AVR, or actually in this case, it's just a bridge rectifier. And then we'll test the ohms through the brushes to the rotor. The brushes seem to be in good shape, so I'm just loosely going to reinstall them. I don't actually want to connect them back to the bridge rectifier because that'll kind of skew the reading that I want to take. Now, the rotor on this generator, it should be around 30 or 35 ohms. And when testing it through the brushes, it is going to add 100, maybe 200 ohms, which is fine. I just want to see that the rotor is not open circuit, because that is typically how they fail. They spin at 3,600 RPM and the wires weaken and break. So if I get any reading around 200 ohms or less, I'll be pretty happy. Yeah, it seems like a good reading. 86 ohms. Let's check it to ground. And there's a connection to ground. So that's the problem. The insulation on the rotor failed, and it's shorted to ground. So there might be a chance with this one. I do have, I think, one Powermate rotor. I have no idea if it's compatible with this Powerhead, and the only way to find out is to uninstall this Powerhead, which has to be done anyway. So let's get the stator off, we'll get the rotor off, and see if there's any chance of swapping that out with the one I have. Change of plan. I'm going to start the engine before pulling the Powerhead off. I want to make sure that there's no surprises. And there's plenty of oil. Needs to be changed, but it's fine to test with. That engine sounds great. It started first pull, and the carburetor is doing a good job. So for once, I may not have to clean that carburetor. The seller did tell me he cleaned it out in order to get this generator running, and that's when he realized it wasn't making power. So I think we're good to proceed. Anyway, before pulling that stator off, I actually have to get the exhaust system off. This one is kind of a unique design. There is a bracket right here, which is bolted into the core of the stator. So until that's removed, I'm not going to be able to get that Powerhead out of there. Yeah, hopefully this will do. Usually I slide a piece of wood under the engine to support it, because once I get that end of the stator off, you lose the support for the engine on that side. Anyway, I've got the strap wrapped around kind of the bell housing, so that should support this well enough so that when I get the stator off, this won't flop and hit the floor. was wondering why that stator wouldn't come off. Once I cracked the seal, usually they slide right out, but not this one. I did have to apply leverage, which you don't normally have to do, but now I can see why. This piece here is broken, and clearly this was making some contact with the stator. Why? I'm not sure. Potentially the stator was just misaligned, but my money would probably be on rust. You can see a bunch right here. Most likely that got caught between the rotor and the stator and just created some drag, and this plastic piece just couldn't survive that. So once it broke, it allowed these wires to shift a bit, and I'm sure the insulation failed right in this area. Anyway, let's get the rotor off. I'm going to do the easy thing here and just strike it with a hammer until it pops off the tapered shaft. Usually I don't recommend that unless it's a last resort, because you can cause damage to that rotor. And in this case, the damage is already done. The bad rotors on the left and the good spare on the right. And you can see they look almost identical in every way, except for one. The good rotor is short by about half an inch. So although the stator is good, without the proper rotor, I can't use it. So I'm going to break out the other bad generator and see if I can't make two bad into one good. This is the other broken generator in question. It has a Subaru EX30 engine on it, which threw a rod and punched a hole in the side of the block. So this engine's done, but everything else on this generator is in very good condition, including the frame itself, which is a good thing, because this one, besides being weathered and having two flat tires, I don't think is going to work with the stator on this generator, because the mounting location for the stator is toward the back, and on the Powermate it's actually more in the middle. So as a result, the crossmember that supports the stator, it's too far forward. It needs to be further back in order for the good stator to work. So this frame's out, this one's in. The actual swap, I think it's going to be pretty easy. Both of these are 300cc engines. They have the same tapered shaft, same bolt pattern for the bell housing, and I even think this one's going to drop onto the existing engine mounts without having to move them. So it should be fairly straightforward, but I do foresee at least two issues. First, the clearance on the airbox is very tight on the Subaru, and the Yamaha has a larger airbox, so that might be an issue, in which case I will have to relocate the mounts and just slide everything back a couple inches to get the clearance I need. The second issue, and probably the bigger one, is the exhaust system. The one that came on here is pretty unsightly, not to mention it mounts on the stator. This stator cannot accommodate that mounting location, so that is an issue I'm going to have to figure out. I do have another Yamaha exhaust. It's actually from a Yamaha clone of an MZ360, which this is not. This is an MZ300. So I don't know if it's compatible until I try. So I'm going to break this one down in a very similar fashion. We'll get the tank out of the way, get the power head off, only this time without using a hammer, and start piecing together a working generator on this frame. In this case, I'm going to use a rod cut to size to push the rotor off. It's fairly effective at removing rotors, but you can't always use this method because the rotor bolt comes in two diameters. This one is an M8, which is fairly narrow. It actually goes in the shaft and has a lot of slop, which means you can use a larger rod to push against the tapered shaft and it won't damage the threads. But some rotor bolts, they are actually an M10 and there's no slop at all. So the only rod you can get in there is the same size and that will damage the threads. So in that case, I use water to build hydraulic pressure. But this one, don't need to do that. So the idea is you just insert the rod. This one's already threaded. You want to make sure you can at least get a few threads to engage before it tightens up. And now just torque down with an impact and that rotor should pop right off. I was getting worried there for a second. I thought I might be stripping the threads out. Thankfully, it did release from the tapered shaft, and the power head came off in one piece. So I'm going to set this aside someplace safe and just continue on. I want to get this blown engine out of the way, but first, I'm going to drain the oil. No big clues in the oil. It might be a little low. It should have been enough to keep this engine running. So I'm not really sure what led to this engine's failure. My best guess would be someone ran it on a hill, and either the oil sensor doesn't work or it was positioned in such a way that the oil went away from the dipper, but the oil sensor was still satisfied. I'm not sure. Anyway, let's continue. It fits, but only just. I have the engine mounts installed loosely, and the airbox, the clearance on the bottom, I'd say is acceptable, but on the top, it's touching the frame. And that's going to rattle, make a lot of noise, and potentially break that airbox. So I do need to slide the engine back a bit. But I do need to be mindful of how far, because the stator from the bell housing to the end, it's 14 inches long. And when you get to 15 inches, it's up against that tire. So I don't want to move it too much, not to mention the wiring from the stator to the control panel may not have enough slack to do that. So I'm going to shift this maybe by 1/4 of an inch or 1/3 of an inch to the left and call that good. Much better. Plenty of clearance now. It's better than the Subaru. I think we'll be fine. So I'm going to take a second, just clean some of this stuff off and move on to that Powerhead. I've already loosened these stator mounts. I'm going to leave them here for now until the Powerhead's installed. Then I can see exactly where they should go. This bell housing also has to be swapped out. I've already cracked these bolts loose, so I'll get those off and put the correct bell housing on. The bolts that we're holding the Powermate on are pretty short compared to the Subaru. And that is a bit of an issue because this bell housing here is quite a bit thicker. And that bolt barely sticks through. So I'm going to stick with the Subaru bolts. They actually might be a bit too long. If that's the case, I'll just cut some of it back. Anyway, I'm going to put some thread locker on here. Usually they are held in place with thread locker. On the Subaru, not really seeing any signs of that. But the bolts that came out of the Yamaha definitely had some on there. And it's a good safety measure. I mean, these should bite in anyway, but that's just a little bit of extra protection. Before torquing this bolt down to 18 foot-pounds, I'm going to build a shoulder on it. It's an 8mm bolt in diameter, and the shaft is a little bit over 10 millimeters, and as a result, there's a lot of slop. And when you torque it down, it's going to go to one side, which isn't a huge deal. That's the way it comes from the factory, but I think it makes sense to just build a shoulder with electrical tape while we're here to help center that bolt. Also, the slip rings, you can see there's a lot of carbon buildup, and it's actually hard to get a reading through all this. I tested this Powerhead before uninstalling it to make sure everything was good, but this here, very hard to get a consistent reading. So I'm going to clean that up with a bit of Scotch-Brite and then get that stator on. Just make sure to watch out for these wires. There's one on each side, which connects the rotor to the slip rings. I just removed the spark plug so there's no compression. I want to turn the engine over and listen. I want to make sure that the rotor is not making any contact with the stator. And we're good. It's a lot less hideous than I thought it would be. So this, I would say, is an option, but now that it's in place, I can see there's a couple other issues. First, the exhaust is a bit higher than I thought it would be, and it's going to be maybe a little too close to that fuel tank, but some of that is due to the fact that I can't actually drop it all the way in place. The bracket is causing interference, and you can see that stud there, it's barely poking through. So at a minimum, I would have to cut some of that bracket away to allow this to drop into place properly so that I can bolt it down to the head, and then get a little creative and somehow figure out how to attach that to the stator. Before doing that, let's try this one. This is the one from the MZ360 clone. The mounting is different. It actually attaches to the end housing. There's a bolt hole here, and I think the other one's right there. The only catch is the length has to be exact. So let's drop it in, see if it has any chance of working. Yeah, this one's going to be perfect. So I think I dodged a bullet on this one. I'm going to clean out those bolt holes. They are full of dirt. And I'm going to uninstall the front of the heat shield. I do want to paint that up, but there's no reason I can't install the rest of the exhaust while doing that. It's really close, but I do have to elongate this hole just a bit in order to get that bolt to go in. Unfortunately, this bolt, it's not going to work. It's the right thread. It goes in, but the flange on the side of the bolt hits this housing, and it can't actually make it to the bracket to clamp it into place. So I've already checked my stash for a bolt without the flange with this thread and came up empty. So instead, I'm just going to use a nut as a spacer, and that should be good enough to clamp down on this bracket. This control panel was just barely holding onto the frame. Most of the screws were missing but one, and I had assumed if I replaced the screws that everything would be okay. But now that it's off, I can see that is not the case. This plastic back here, it is cracked, and everywhere a screw goes to secure it is also cracked and broken or just missing chunks. So unfortunately, this control panel can no longer be used in the way that it is, but I do have a spare, and it's essentially the same exact thing. So I was going to go with this, but there is one important difference. This one has a quick disconnect, unfortunately. So I can't use this one as is, but this plastic backing here looks to be the same part. So I'm going to try to swap the backings so that I can make this one usable again. Get that spider out. Similar to the slip rings, it was very hard to measure any resistance through here, so I'm going to swap out the wire block with one that's in better shape. Forgot the jumper wire. This generator is bonded to the frame, so the neutral needs to be connected to the ground. Although the Subaru engine had a low oil system, it didn't have a low oil light like the Yamaha does. So I pulled that light out of the old frame, and a lot of times what manufacturers do is just bundle this up and zip tie it and let it dangle off the side of the block. But I think it can do a little bit better than that. I'm just going to drill a hole somewhere, probably in this area, and mount that light. Also need to do something similar for the ignition switch. think I'm going to give the Subaru switch a try on the Yamaha. I think it might be a better solution on this frame instead of using that other switch. Yeah, I think that's going to work out pretty well. Similar to where it was on the Subaru, and a lot of Hondas and Honda clones put their switch there as well. So let's get the blower housing off and get this switch installed. That's not OEM. I'm not sure what that is. Luckily, I have one of these on hand. I actually bought it for another project, which I haven't started yet, so I think I need to order another. I want to double check the switch real quick. The way the Subaru switch works is that it picks up the ground from this screw here on the right that goes into the blower housing. And when you flip the switch to off, it passes that ground through this wire and then down to the coil. So I just want to make sure that the blower housing is grounded well. So I've got one lead connected to the engine ground, multimeter set to test continuity. I'm going to hold the other lead to the wire coming out of the switch. And yeah, that switch works fine. So I'm just going to connect it up to the coil, and we should be good. So what do you think? Is it going to work? I hope so. I mean, that Powerhead, it's unproven. It came with a blown engine, but I think based on the testing, it should work. So the plan is to get it started. We'll check the voltage, see where we're at. Most likely the AVR is going to need a small adjustment. Also, I've got the multimeter connected to the 240 output. That's just to verify I wired that properly, because if I did it wrong, I could have a scenario where I get 120 out, but get nothing on the 240. So we'll double check that. Assuming everything's good, we'll put it under a 5,000 watt load and see if it can hold. A little bit hard to start, but it did start, and it ran pretty well. I did notice the carburetor was flooding over, and I think that's what the stuttering was at the end, because when I turned the fuel valve off, the engine smoothed out and ran perfect. But when I turned the valve back on, it started acting like it was running rich. So right now I have it turned off. We'll have to dig into that. Most likely we need a new needle, but it had no issues really powering a load, although it did give me a scare for a second. I turned all of these on full, which is actually 6,000 watts, and the generator went to stall because this engine cannot pull that load. It's only rated at 5,000 watts. So I backed that one off a bit, and we were still pulling 5,250 watts, and the engine had no issues at all holding that load, and the voltage also is pretty much dead on. So I don't think I need to make any adjustments there. I think I can get that cover back on, but I do need to drop the bowl on the carburetor and see what's going on with that needle. And just to show you here, you can see it's actively dripping. I did shut the fuel valve off, and the grass right there is going to be dead in about a week. So yeah, that bowl needs to be dropped, and at a minimum, that needle swapped out. So let's give that a try. Just going to turn the fuel back on. Yeah, that needle is doing absolutely nothing. And I'm killing all my grass. Got it. Needle doesn't look terrible, although I do see that ridge going all the way around. So yeah, that's probably the issue. So we'll give this new needle a try, and that should take care of this issue. I see the problem. The carburetor has a broken arm on the other side, and that's why it couldn't seal properly. So yeah, although the carburetor runs the engine well, it's not going to work. So let me pull that off. I just popped the airbox off so you can see a little bit better. The pin goes all the way through, and there's two arms that hold that pin in place, and that arm is broken off and not holding things in place. So I do have a clone carb. It looks brand new inside, and the Yamaha clones usually run the engine pretty well. So I'm going to pull that off, put this in its place, and we'll try this again. I've had the fuel turned on for about 10 minutes, and this one is good. It is not leaking at all. So let's get it started. We'll do the same test again real quick, and just to make sure that this carb can run the engine as good as that other one. That clone carb thankfully runs, I would say, as good as the OEM Mikuni. And it figures, the one time the seller actually cleaned the carb for me, I thought I was all set. And in this case, he was a little bit too rough and broke the arm off this carburetor. So unfortunately, this one is parts. And this whole entire machine was made out of parts from 4 broken generators. And in the end, we've got one good one that's doing exactly what it should. So I hope this video helps someone. Thanks for watching.